Okay, let's jump right into this explainer. Now that we've completed modern Java features like Lambdas, streams, and optional, let's combine them into a real data processing application. Today, we aren't just looking at isolated code snippets. We're building a comprehensive student data processor from the ground up. If you've ever felt bogged down by clunky loops and massive blocks of conditional logic, you are absolutely going to love how elegant Java can be when these modern tools work together. Here's our quick roadmap for today: the student data project, building the stream pipeline, handling the null threat, real-world app optimization, and a micro-challenge to wrap things up. Let's get to it. Section 1. The student data project. We are going to build a functional program that does 4 specific things. It needs to store student data, filter it based on certain conditions, transform that data to get exactly what we need, and, this is a big one, handle null values safely. Because let's face it, real-world data is rarely ever perfect. Step 1 is defining our data. We have a simple student class with a string for the name and an integer for the marks. Notice we're using the object wrapper integer instead of the primitive int. That's going to be crucial for our null handling in a bit. Step 2, we create our data set. We've got Alice with an 85, Bob with a 60, David with a solid 90, and then there's Charlie. Charlie's marks are null. Keep your eye on Charlie. He represents the messy, unpredictable reality of raw data. Moving right along to Section 2, building the stream pipeline. Before we write any code, let's make sure we're on the same page about what a stream actually is. It's fundamentally different from a collection. While a collection is all about storing data, a stream is about computing it. It's a sequence of elements from a source that supports aggregate operations. And the coolest part? It computes elements on demand, which is what we call lazy evaluation. To really visualize this, think of a collection like a movie stored on a DVD. The physical disc holds every single frame of that movie in memory before you even hit play. A stream, on the other hand, is like watching that same video streamed over the internet. Your player only loads a few frames at a time, computing and displaying them on the fly. With collections, you have to write loops to manually iterate through the data. But streams, they handle all that iteration internally, entirely behind the scenes. So how does this look in practice? We take our list of students and call .stream. From there, we just chain our operations. We filter for marks strictly greater than 70, map the stream to extract their names, and then print them out. It honestly reads almost like plain English. Stream the students, filter by marks over 70, map to their names, and print. And under the hood, those Lambda expressions are just implementations of Java's functional interfaces. The .filter method expects a predicate, basically a function that takes our student object and returns true or false. If true, the student stays in the stream. The .map method expects a function, which takes one value, like our student object, and returns a completely different value, like the string of their name. Simple, right? But wait, Section 3, handling the null threat. Pattern interrupt time. Let's consider Charlie again. His marks are null. What exactly happens when Java tries to evaluate if null is greater than 70? Boom, a dreaded NullPointerException, and our whole program crashes. In the old days, we'd clutter our code with messy not equals null checks to filter him out early. But modern Java gives us a much better way. Our ultimate defense against bad data is optional. By wrapping the marks in optional.ofNullable, we explicitly acknowledge that the data might be missing. Then we just chain .orelse0. This tells Java, hey, if the marks exist, use them. If they are null, just substitute a 0. So Charlie gets a temporary 0, which safely filters him out without breaking our pipeline, or forcing us to write ugly if-else blocks. All right, Section 4, real-world app optimization. Let's talk about scaling this up. These patterns scale up beautifully. This exact pattern is used constantly in enterprise data filtering systems, backend APIs, and analytics pipelines. You can easily extend this project by doing things like sorting students, finding average marks, or writing results directly to a file. Plus, there's a massive performance advantage. Simply changing .stream to .parallelstream tells Java to automatically break up your query and use all your CPU cores concurrently. You get the power of multi-threading without writing a single line of traditional thread management code. It's actually such a game changer that researchers from the City University of New York built an automated refactoring tool for the Eclipse IDE to help developers optimize streams. Their tool uses static analysis to figure out exactly when it's safe and efficient to swap a sequential stream for a parallel one. When they tested this across hundreds of thousands of lines of code, refactoring to parallel streams gave an average performance speedup of 1.55 times. That is literally free performance just for understanding how stream architecture works. Which brings us to section 5, our micro challenge and wrap up. Here is your micro challenge. Look back at the pipeline we just built. I want you to pause and think about how you would modify this program to print only students with marks above 80. What exactly needs to change inside that filter method to hit that new goal while still keeping our null safety intact? Whether you just solved it in your head or jotted it down, you probably figured out that you simply changed the filter integer to 80. This project perfectly demonstrates how modern Java features, Lambda expressions for concise logic, streams for your data pipeline, and optional for null safety, combine to create incredibly clean, safe, and efficient data processing logic. And with that, you have now completed the Java course. Continue practicing by building more projects and applying these concepts in real applications. Look for every single opportunity you can to transform clunky loops into elegant pipelines. So now that you've mastered this, what raw, messy data set will you transform next? Thanks for hanging out with me on this explainer, and happy coding!